uploading right now. So we did this. We found out that the discriminant is 84 and it's positive, so that means we have 2 roots. What about this now? Try this guy. And again, you could actually program your TI to ask you what's A, what's B, what's C, and it would figure out the discriminant for you. If you want to write that program, all you got to do is YouTube, and I'm sure there are people in the world out there ready to teach you. So I'm going to bump to the right, actually, because I put an equal sign down here that doesn't really belong. I know, you guys can't see what I'm writing, which was fine, but now I'd like you to see what I have. So b squared minus 4ac. B squared, 64. Whether this is positive or negative doesn't really make a difference to the discriminant, right? Because we said it squares and it's going to become positive no matter what. Minus 4. Now A is negative, so that adds a layer of interest there. So when A or C are negative, what's going to be interesting here is that string of multiplication, 7, 14, 21, 28, 56, makes minus a negative number. And what's minus a negative do? Yeah, it just adds. So this is actually going to come out to be 120. So if our discriminant is 120, what's that tell me about number of roots? 2. 2 real roots. All right, so that's when just A was negative. What about when A and C are negative? Try this one. And please stop me if there are any questions. I know I moved on from that last one kind of quickly. Please stop me if you'd like to ask anything. We can sing the song in our head. Well, okay, so now we've got minus 4 times negative times negative. We've really got 3 negatives here, so if I push the whole thing together, it really stays negative. Right? 16 times 9. Ooh. 144. Which is 0. Which means there is 1 uno singular, 1 real root, right? 1 real root. Now, actually, if we think about the shape of this, this has been flipped upside down, but then shifted up. This has been flipped upside down, but then actually shifted down, right? So our y-intercept can help us like recognize what has happened or where have things gone. I think I got 1 more of these for us to do. Nope. So the reason I don't have 1 more of those is we can just keep solving discriminants all day long, and the only other case we'll see is when it comes out negative. We have no real roots. Really, we have lateral roots, and quite frankly, I don't want you guys to get too much in the habit of saying no roots. I want it, like, we don't have real roots. Okay, so there's a difference between no roots and just no real roots. which really everything, I think we're arguing, everything has a root. Which, by the way, if you're curious about the YouTube video, and especially because I stopped the recording, so if anyone is watching this recording as part 2 from today, all you have to do is YouTube search imaginary numbers are real, and then literally, I loved it so much, they have this for sale on their website. It's from Welch Labs, so like a legitimate, like company. So we have a little workbook for imaginary numbers are real. We'll probably do a little unit on this, like maybe like a week or so. There's really good stuff in here. So if you want to leaf through this, let me know. I don't know that I would let anyone borrow it because I'm kind of possessive. What? I'm being honest. You guys are 8th graders. You lose things or, they get like... Alright, so the next thing you want to do is draw a squiggly line or start a new piece of paper for completing the square. The quadratic process called completing the square. What in the world does this mean? Today's the 8th. I don't know if we put a date on our last page. We should have. So, interesting. Based off what's on the board, I wonder if anyone can make a hypothesis. Actually, right here, you're 1A, right? Yeah, you come to me in the morning. Yep, that's perfect. Thank you. I'm going to set this out there. You're like my little sign. That's over here. Anyone have a guess what completing the square means? No. Is there a square up there? Yeah, there's a square up there. There's a square with other squares, it looks like. Who what? Yes, this is not one of those. So, if we think back to perfect square equations, this is saying, what is the missing constant term in the perfect square that starts with x squared minus 8x? So let's write down x squared minus 8x. So like f of x, right, if we're going to make this a function. And I'm going to say plus something, because it says, it's prompting me that there's a missing constant. Now, if we draw a square out here, this is also why I love graph paper. Let's draw a square. I'm going to make mine like 6 by 6 or something like that. And we think back to one of the methods that we were able to use to factor things. Remember when we broke up our trinomial like this? And we know that we're going to have an x out here and an x out here because of that. And then if it was a perfect square, this dimension this way should be equal to this dimension this way, right? If it's a perfect square. Yeah. So what do I have to do with my bx value? Do I just put like negative 8x right here? No. Oh, so do I put negative 7x and negative 1x? No. If this was a perfect square equation, how would we have set? Yeah, we split it in half, right? Guys, I even, on this slide, it said 1/2 b, 1/2 b. Haha, look at that. So I split it. Negative 4x, negative 4x. So that means I have a negative 4 right here, and a negative 4 right there. So what that tells me is it was x minus 4 squared is our equation, right? If, big if it's a perfect square. Now, If it's a perfect square, what does this have to be? 16. Can anyone make a guess or a conjecture of a rule we might be able to apply to find the missing constant? Now, hold on. I'm going to let you think for a moment while we write down if we have x minus 4 squared, then the constant is 16. And that if is because if we want to break up our bx, over here we have half b and half b, leading to the minus 4 and the minus 4. All right, so I mean, if we tried this with like some other, so this is what we just did, the x squared minus 8x, right? What if we tried this? I want to give you a second to try this on your own in case you haven't sort of figured it out yet. What if we tried it with this or with this? What would be the missing constants if these were the start of perfect square equations? Take a couple minutes to try this on your own, then we will come back together to talk about it. I'm trying to check what time we leave here. 38, okay. Oh, you guys told me you can't, really. Well, that all because you want to doesn't mean you're allowed to walk down there early. What you need to do is math. Uphill both ways. Wow, great story.
That's exactly what I do all my mom. Nope, never ever.
All right, x squared. The conversation's way off topic. I'm going to try to pull us back in. X squared. If we split our bx, because we said we have half b in each of these, we'd have 9x. So then what would our constant become? 81. For x squared minus 12x. Can anyone just tell me, like, without even setting up the square, can anyone tell me how we could figure this out? L? L? So. B? Can you give it to me in any other way? So you're saying this is going to be 36? Can you say it in any other way? There we go. If perfect square, our C is going to equal 1/2 B squared. Because what we wanted to do up here is make it into x plus 9 squared. And when we FOIL that out, we get 81 as the constant. In our red equation that I wrote here, this we want to make
Good morning. Please pardon the interruption. At the lunch break,
x minus 6 squared.
stop by the remote office. Thank you.
So if perfect square, the constant that we want, oh wait, crap, he said want. That might mean that sometimes it doesn't work out. The constant that we want is 1/2 of b squared. That doesn't mean that always is what it is. So if you were given this equation, x squared plus 2x minus 3. So what we want to set up first, I'm going to squiggly line because we're kind of changing gears. I know you can't see my page yet. That is perfectly fine. Write down the trinomial, please. X squared plus 2x minus 3. Now, there are two distinct ways to solve these problems. I would like to show you both, but I have just about 10 minutes left. That should be enough time. One way is completely ignoring the constant on the left-hand side. And by that, what I mean is we just move it. We like to move it, move it. We like to... No? Okay. So if we move it, it comes over to the right-hand side as a positive 3. That allows us to say, okay, this is what I'm working with. You can't see my paper. If we move it to the right-hand side, it allows us to act like these problems up here, right? Okay, what is my missing constant? What is the constant that I want? So then we're allowed to set this up like, okay, x plus, wait, what did we say this number is? Ooh, that's the constant is 1/2 b squared. This is just, if we look up here, 9 compared to 18, negative 6 compared to... Ah, this is always half of b. So, half of b, okay, 1. What? It's not 1? Why? But it is right. You want to take over? You want to take over? I can give you the thing full of Sharpies. Yeah, I do. So, half of b, right? Because when we FOIL this out, we would get x squared, 1x would be our outer, 1x would be our inner, making the 2x. What would our constant be? Well, if this is our trinomial, we know this is x squared plus 2x plus 2. Now, can I just... Wait, 2.
What are you doing?
If you want to correct a mistake, here's your opportunity.
I told you not to do that.
Not to do what? You didn't tell me not to do this.
No, I told you not to put 1
This one is supposed to be there. It's still not that. Guys. Thank you! This is not 2. This is 1. I was trying to give you an opportunity to actually correct a real mistake, not like a made-up mistake. So, now wait. This, hold on. We still said this, wait. This is not equal to 3, though. Because this is not what we have. This is a giant if. If we have a perfect square. If we make this happen. But to get the plus 1 to make this happen, we need this constant of, well, okay. So if I make this plus 1 up here, I also have to plus 1 over here. So here's one method. One method is to move your constant off of the side that, like, with everything that you're working with. It doesn't matter if it's left or right, so I don't like saying left or right. Move the constant completely. Figure out what constant we want, and then add that on both sides. What we now end up with is x plus 1 squared works now because we added 1 to both sides. So my left side is now x plus 1 squared equals 4. Thank you, because the right-hand side had 4 added. So if I want to put this back into quadratic form, it becomes, sorry, I'm going to write real small down here, x plus 1 squared minus 4 equals 0.